Okay, so now we can link back to the purpose of today, which is to look at another kind of instructions than I/O, namely QuickCheck instructions. And to recap, what we talked about in the short lecture about type classes was that QuickCheck can perform random testing, providing the values that it's going to have to generate are a member of a class called arbitrary with a big A. And for any type T in arbitrary, what is the most important operation in the class arbitrary? It's the operation arbitrary, which we can view as instructions for generating random values of type T. So this gen thing, which is what I'm calling instructions for generating a T, is something in the class monad. So this is another kind of instruction. So what that means is, when we build things of type gen T, we will use the same kind of notation we used to build instructions of type I/O of something. In other words, we will use do notation as our main building block for building things of this type. So to compare then I/O versus gen, two different kinds of instructions. These things live in completely different worlds. I/O is special in many ways. It is the Haskell way of dealing with input-output. It's the Haskell way of reconciling having pure functions on the one hand, but still being able to do things with side effects on the outside world on the other hand. So I/O is something which is built into Haskell. It is part of the infrastructure of Haskell. So when you see something of type I/O of T, you can think of this as instructions to build a value of type T by interacting with the operating system. And you can ask yourself the question, when do these instructions get run, or rather who runs them? And they're run by the GHC runtime system. In other words, the way that these are run, the way that these are executed, is built into Haskell. Of course, we can build our new instructions from old ones, but the primitive building blocks of instructions are things that are built into Haskell, built into the GHC runtime system. Gen T, the instructions that we're going to look at today, are instructions to create random values of a certain type. But these are instructions that are not run in the same way that they're run here, just by typing something of type I/O at the command prompt. These are run by QuickCheck internally. So whenever we run QuickCheck on a function, the instructions, the Gen T instructions, will be those instructions used by QuickCheck to generate random values in order to perform its random tests. Okay, so let's have a look at the instance arbitrary. Let's ask for a bit of information about it. And what we see when we ask for information about it is that there are lots of instances of the arbitrary class. And that's basically telling us that for most of the standard functions, standard types, the Haskell standard types, QuickCheck knows how to generate random values for them. And that's how we've used QuickCheck so far, with the exception of Lab 2, where we were using our own data type. We were using the fact that QuickCheck knows how to generate random values. And that's because there are generators for random values for many types. And this list shows that there are lots of them. So how do we actually see that they're there? Well, we know that QuickCheck is using them to generate random values, but is there some other way we can explore them? So in other words, we can look at this arbitrary guy, it's a generator for A's, and we can inspect it by using some QuickCheck functions, namely sample and sample prime. So let's have a look at them in action. So let's sample arbitrary. In order to sample arbitrary, we need to let QuickCheck know what type we're thinking of. We're going to sample this generator, the standard generator called arbitrary, but we need to actually tell QuickCheck what type we're interested in sampling, because this is an overloaded operation. So which one of all the family of possible members of the arbitrary class do we mean? We're interested in, let's say, a generator for booleans. So this sample then will allow us to look at the generator for booleans, and it will do so by running it by generating a bunch of random values, printing one on each line. So let's take the same example again now, but now with integer. And excuse the out of control scrolling there. And then you will see some fairly standard QuickCheck strategy here. QuickCheck will almost always start with 0 when you start with numbers. It will start with the simplest things first. It's maybe interesting to look at what the difference might be with int. Not much, doesn't look very different. Maybe as values get bigger. Now, QuickCheck knows how to generate lots of different things. We could ask for lists of ints, for example. We could ask for lists of pairs of ints and characters. Oh, well, there are lots of unprintable characters that get printed. They're shown there, so that's not such a nice example. Okay, so that's sample. We'll just allow you to inspect a generator. And there's a related function called sample prime. Let's take sample prime for int. So let's not take sample, but sample prime. And sample prime will put them all into a list. It generates a list of, in this case, int, but it will then generate a single list. So that's sample and sample prime. What's the type of sample? Well, it shouldn't be too surprising to see that IO is in the type here, because sample, when you actually run a generator, you're trying to generate random values. But since Haskell is a pure language, the only way to get any kind of random behavior that is not the same every time you do it, would be to actually end up in IO, so that you can actually get some randomness from the operating system. So sample requires that you have a type which can be a type A, which can be actually printed on the screen, firstly, and then you give it a generator for that type, such as arbitrary, which is the standard generator that QuickCheck knows about for many types, and it will run it a bunch of times. Sample prime has a slightly different type. In sample prime, the list is actually delivered as the result. In this case, there's no result delivered. The samples that it creates are simply displayed on the screen. In this case, the samples that it creates are delivered as a result. So sample and sample prime, we use those when we're building generators to explore them, to see what they do. When we want to run the generators, we can use sample and sample prime. These are just functions from the QuickCheck library.